Alright, we've covered a lot of things. Let's recap all of them before moving forward. First of all, it's useful to think of validation in terms of the set theory, and that's what we're going to do throughout this course. A set is just a collection of elements. A set could be finite, in which case it would contain a finite number of elements, or it could be infinite. For example, a set of all numbers is infinite because there is an infinite quantity of numbers. Or, as in our case, the set of all possible strings and the set of all possible email addresses are both infinite as well. Note that although these two sets are both infinite, we can still differentiate their sizes, or cardinality if we are using precise math terms. The cardinality of the string set is greater than the cardinality of the email set. That might seem confusing at first. After all, how can we compare two sets that are both infinite? But it does make sense if you think of it as of a more dense versus a less dense continuum. For example, the set of all natural numbers is infinite, as is the set of all real numbers. But you can fit in a lot of real numbers in between any two natural numbers. In fact, you can fit in an infinite number of them. Therefore, the set of real numbers is more dense than the set of natural numbers, and thus its cardinality is also greater. The same goes for strings and emails. Another important concept in the set theory is the notions of superset and subset. A superset includes all elements from its subset. For example, the set of all strings is a superset for the set of all emails. Conversely, the set of emails is a subset of strings. The set theory is useful when talking about validation because it helps visualize a lot of concepts related to it. The validation itself can be defined as the process of mapping a set onto its subset. This is the process of trying to find whether an element in the larger set has a corresponding element in the smaller set. We also discussed the first building block of the good validation technique, the concept of always valid domain model. All domain classes should guard themselves from ever becoming invalid, otherwise it becomes hard to work with such domain classes, because you never know whether they were validated or not. In terms of the set theory, a not always valid domain class can be visualized as a set that has been chosen incorrectly. For example, if our student class can potentially enter an invalid state, then we effectively include those states in our student set, and thus misalign the two sets, the set we've chosen to model the student and the set for the underlying student concept, as it is viewed from our domain perspective. This is the same issue as using strings to model the concept of email address. The set of strings is larger than the set of emails, and therefore isn't suitable for that task. To fix this issue, we need to shrink the set of states our student domain class can be in down to only valid student states. You need to adopt the following mental model when thinking of validation. This is your domain model, and this is the external world your domain model communicates with. Your domain model should be valid at all times. In other words, you should use precise sets when modeling your domain entities and value objects, such that those sets perfectly align with the sets for the underlying domain concepts. On the other hand, the external world may and will be invalid. Your goal as a developer is to protect the domain model from the influence of the external world and don't allow its invalidity to infiltrate when the two are communicating. You implement this protection via validation, the process of differentiating requests that are valid from requests that are not. Invalid requests get rejected with a 400 response. Only valid requests are allowed to go through and affect the domain model. Let's now move on to the next building block of the good validation technique, and that is the difference between validation and invariance. But first, what is an invariant? In domain-driven design, an invariant is a condition that your domain model must uphold at all times. For example, a triangle is a concept that has 3 edges. And so this condition is inherently true for all triangles. Your domain class triangle should protect itself from having fewer than or more than 3 edges at all times. So what's the difference between validation rules and invariants? There is a misconception here that I'd like to debunk. People often view input validation and invariants as different concepts. This is not correct. In fact, these two notions are exactly the same. Let me explain why. Invariants are something that defines your domain model. If you create a triangle with 4 edges, you wouldn't call this figure a 4-edged triangle. That so-called triangle would simply cease being the thing you expect it to be. It would become a square instead. The presence of invariants leads to the need for validation. In fact, the only reason why we need validation is to make sure that all invariants of our domain model are intact. Invariants are the differentiating factor between valid and invalid domain model. They are what dictates our validation rules. For example, the checks for email address validity are there only because our application domain requires all email addresses to adhere to certain rules. These rules are invariants. They define the concept of email address in our application. Without them, the email address would cease being an email address. For instance, a string without an @ sign is not an email. If we go back to our metaphor with the set theory, then the invariants are the rules by which we map incoming requests onto the domain model. These invariants are the rules that we use to differentiate valid and invalid domain objects. This equivalence between validation rules and invariants leads to some profound consequences. First, all validation rules belong to the domain layer. That's because invariants are an intrinsic part of your domain model. They represent an important piece of your application's domain knowledge, hence they should reside in the domain layer. The second consequence is related to another misconception, and that is the difference between simple and complex validations. Oftentimes, people differentiate between the two by calling simple validations data validation and complex validations business rules validation. By this logic, checking that the student email contains an @ sign would be data validation, while checking that you can enroll the student into a course business rules validation. This is incorrect. Data validation is the same as business rules validation. They both represent your application's invariants. The only reason why people segregate them is to rationalize having two ways of handling input validation. Simple validations are normally tackled by frameworks, such as Fluent Validation, while complex validations by controllers. You may also hear that complex validations have a business meaning, but simple validations don't. This is also a misconception. All validations, no matter how simple, are part of the domain layer. The only distinction here is that some validation rules are simpler than the others. Alright, this is quite a strong statement that all validation rules, even the simplest ones, belong to the domain layer. It probably makes sense to you that checking for the @ sign in an email string is part of the domain knowledge, but is it truly the case for really simple validation rules, such as checking for the maximum length of, say, a student name? Does this check of the string length also belong to the domain layer? Yes, it does. These field-level validations might look like a technical constraint at first. After all, it's not the business expert who specifies that the student name must be less than 200 characters long. It's likely the programmer who selected this constraint, and he did that rather arbitrarily, or using his past experience. But this view that simple validations are purely technical constraints is not entirely correct. Look at it this way. What if you make the student name 2 characters long instead of 200? The domain expert will surely disagree with this technical implementation detail. In reality, max length constraints are the result of the negotiation between business requirements and technical limitations. Domain experts may love to have an unlimited student name field, but that's not technically feasible. Similarly, a two-character student name is perfectly valid from a technical standpoint, but it is a deal breaker for the domain expert. So again, all validation rules, however simple they are, come from business requirements, at least partially.